This is a demonstration of the Ranger Radiation Survey Meter. The unit is an integrated internal pancake GM detector. It is used for general-purpose survey of alpha, beta, and gamma radiation. I will check the Ranger's response to cesium-137 for gamma and beta radiation, strontium-90 for beta radiation, and plutonium-239 for alpha radiation. The radioactive isotopes I am using are low-activity test sources. Do not attempt to handle radioactive isotopes unless qualified to do so. Improper use and higher activities of ionizing radiation can cause cancer and other ailments. I will then attempt to detect radiation in some local granite in Massachusetts. This digital meter features multiple units toggled by the mode switch. Microroentgens per hour, milliroentgens per hour, counts per second, microsieverts per hour, total counts over a period of time, and counts per minute. If you choose an efficiency, disintegrations per minute and becquerels are available as well. DPM and becquerel measurements have limited accuracy and utility. For accurate readings in these units, the user needs to emulate the conditions of calibration with geometry, such as placing a source 1 centimeter away from the detector window. Becquerel and DPM modes are best suited for repetitive measurements, such as wipe samples or air sample filters. Operating ranges for the various units are 1 microroentgen per hour to 100 milliroentgens per hour, 0.01 to 1000 microsieverts per hour, 0 to 350,000 counts per minute, 0 to 5,000 counts per second. For total counts, the range is 1 to 9,999,000 counts. The basic system includes the meter, stand, protective boot, the lanyard loop, and the USB cable with Observer software download. There is a dust cover on the back to protect the detector window. This cover will shield alphas and some betas. Options sold separately include the wipe test plate, water-resistant protective case, and a Bluetooth connection for the Android app. The ObserverBLE Android app features data logging and a GPS stamp that is processed on your Android smartphone. An optional NIST calibration is available as well. To start the Ranger, we power on, holding down the power control. The screen displays the system information and icons. After boot up, we can press the light control to illuminate the display. Hold for a few seconds to keep the light on, if you wish. This is the audio control. The audio chirp emulates radioactive disintegrations as they occur. It is useful during frisking to detect a sudden increase. It can be enabled or disabled. The units mode is currently in microsieverts per hour. Press the mode control to switch units to total counts. You can see the time interval is here at 10 minutes. I am changing the interval to 1 minute for this demonstration. Press the menu control to switch units of time. Press the plus or minus controls to toggle a value. Now it is set to 1 minute. For an idea of response, I will place a cesium-137 1 microcurie check source in front of the detector window. We can see the activity in the various units. Sieverts and Roentgens are exposure units. I suggest only using sieverts and Roentgens with cesium-137. Counts are recommended for most applications. Now I will demonstrate a timed count over 1 minute. I press the Enter arrow to begin. The result is 71,330 counts in 1 minute. The alarm function can be enabled or disabled with this control. The threshold is now set at 3,340 counts per minute. The threshold can easily be changed with the plus and minus controls. I will change it to 700 CPM so that the Ranger alarms using our weak source. We can see different units as the alarm threshold using the mode control. The alarm value will always be converted to the units being used when referenced. Press the Enter arrow to enable the alarm. I am placing the source in front of the detector again. That was the alarm. Going back to the alarm feature, I will now disable the alarm. Let's have a look at efficiencies. The default instrument setting is counts per minute, counts per second, which is useful for surveying unknown isotopes. If the isotope present is known, you can choose built-in isotope efficiencies for enhanced accuracy. They include carbon-14, phosphorus-32, sulfur-35, strontium-yttrium-90, iodine-131, cesium-137, cobalt-60, and a general alpha setting. With an isotope efficiency, the user has the option to see units in dpm or becquerel. CPM or CPS is still recommended. I will now attempt to use the becquerel and dpm modes for quantification of alpha, beta, and gamma radiation sources. For an alpha emitter, I am using a plutonium-239 calibration source. I first need to open the Observer software. The default alpha efficiency is set at 4.2%, which is thorium-230. I will change the efficiency to 15%, which is what I estimate for plutonium-239, that we are testing today. Now, make sure the efficiency is set to alpha on the meter. With the dust cover off, I place the plutonium-239 source under the detector using the white test plate. This alpha source was originally calibrated at 44 becquerels and 2,640 dpm. In becquerel mode, the reading is up to 45 becquerels. We see up to 2,900 disintegrations per minute in the dpm mode. Our measurement was close to the readings of the original source calibration, exceeding 90% accuracy. For a beta emitter, I will try to measure this strontium-90 calibrated source in the becquerel and dpm modes. The source calibration values are approximately 201.3 becquerels and 12,077 dpm. First, change the efficiency to strontium-90, yttrium-90. I am placing a strontium-90 check source in front of the detector window, using the white test plate. We see up to 149 becquerels and up to 9,000 disintegrations per minute. The result was not as close to the original calibration as we had with the plutonium source. The Ranger readings were about 75% of the original source calibration values. For a gamma emitter, I will attempt to measure this cesium-137 calibrated source in the becquerel and dpm modes. On the meter, I am choosing the cesium-137 efficiency. I now place the source on the white test plate. The source calibration values are approximately 18,203 becquerels and 1,087,800 dpm. On the Ranger, we see up to 18,940 becquerels and 1,030,000 dpm. The DPM value goes off scale sometimes, indicating that the value is somewhat higher. Exposure rate modes are possible for cesium-137 gamma survey. We see around 64 milliroentgens per hour, which is 640 microsieverts per hour. In CPM mode, we see around 230,000 counts per minute. CPM becomes kCPM at higher levels. In CPS mode, we have around 3,800 counts per second. Comparing Becquerel and DPM measurements with source calibration values, the results are close. We did have some success with the quantification of becquerels and disintegrations for plutonium-239 and cesium-137. For plutonium-239, the Ranger measurements yielded 91 to 97% accuracy compared to source specifications. The Ranger measured cesium-137 activity 4% over the source calibration value. That is considered close to equal within a margin of error. For the strontium-90 source, the Ranger read somewhat less than the original specifications, only 75% of the original value. The reasons for this discrepancy could be a different distance and detector window thickness used by the manufacturer. Furthermore, the drop could have been related to yttrium-90, which is at 1-to-1 equilibrium in the strontium-90 source. Yttrium-90 has a short half-life of 2.66 days, which could have resulted in a lower activity reading. I was impressed that the Becquerel and DPM modes on the Ranger worked this well, but there is always a factor of uncertainty. Now for our outdoor experiment with the Ranger. I will try to detect radiation in local granite. I set auto-averaging off for faster response. I have set the Ranger to CPM-CPS. With the detector cover on, we are not detecting that much background radiation, so I will take it off. The background is fluctuating from 0 to 120 CPM. Now I will take a timed count over 1 minute for background radiation. We see 49 counts in 1 minute. With the cover off, I am bringing the detector window up to the granite, staying about 1 centimeter away from the surface. Remember not to touch the detector to the surface. You want to avoid contamination and damage. Scanning speed should be no more than 1 detector width per second. Frisking should always be performed with the audible indicator on, enabling the user to hear an increase in the count rate. The reading is jumping around, but it seems higher than background. We see a peak at 240 CPM. I will take a timed count to see any deviation from background. I see 90 counts in 1 minute, a significant increase over background. Now I will perform a timed count with the cover on. We see 66 counts over 1 minute, which is slightly over background. Surveying the granite with the detector cover off, we saw the radiation count almost double. I assume we are detecting mostly alpha radiation and beta radiation in the granite. With Bluetooth enabled, We can use the ObserverBLE app on an Android phone, connected wirelessly, as you can see. It mirrors readings from the Ranger. We can observe and record the readings with a GPS stamp of latitude and longitude. The app features a numeric display of counts or exposure, with space for user notes. The units change on the Android app if you change the mode on the Ranger. The app can also perform a timed count independently. We're still connected, but the Ranger can be in another mode simultaneously. The user can save readings and notes as well as generate data logging files at an adjustable time interval. The user can generate compliance reports and share the saved files. Via email, text messaging, and radresponder.net. The ObserverBLE app feeds us raw data, which can be opened with Excel or Numbers software. I did some manual formatting to enhance the report, but it was pretty easy. This is some data from the reading screen. Here is some timed count data. And here is the data logging stream. This is an example of the alarm on the ObserverBLE app, which mirrors the Ranger. Here is an example of the color-coded graphic display with a much stronger radiation source. The graphic display can read in exposure mode only. Let's have a closer look at the menu control options. This is auto-averaging. That means at low count levels, the reading is based on the radiation detected in the previous 30 seconds. That time interval decreases when radiation levels increase. This feature can be enabled or disabled. Auto-averaging is on by default. Data logging. This activates internal memory so that data can be uploaded via the Observer software. It's off by default. Pick efficiency. We went over the isotope efficiencies earlier. CPM/CPS is a setting that's on by default. Set to defaults. This returns all settings to factory defaults. Bluetooth LE. We activate this if we want to use the ObserverBLE smartphone app. Otherwise, leave it off to save battery power. It is off by default. Let's have a quick look at the Observer USB software for your PC. You will see the window appear when you plug in the cable. You can see real-time readings here, and a real-time scrolling graph up here, with a grid of logged readings over here down on the right. Echo is checked, so the display is mirrored from the Ranger. If you want to display different units independently of the Ranger, turn the echo off and choose the various units of counts and exposure. A PC-based alarming function is available. Changing the value so we can hear the alarm, Here is the grid which catalogs and displays readings at an adjustable time interval. We see two values of your choice with a time and date stamp. Micro-hour per hour and CPM are selected for now. You can change the settings of the graph and grid by accessing View, Preferences. From the left, we see Autosave and Clear Chart. Checking this will automatically save and clear the graph at the number of minutes selected. Autosave files are saved to your PC. Use Audible Alarm. This will activate the alarm on your PC's sound system that we just heard. Grid settings. Right to grid. This sets how often a new data point will appear on the grid. Autosave and clear grid. This will automatically save and clear the grid at the number of the data points selected. Here we can change the units on the grid. We can enable or disable the scrolling graph screen here. Exposure or counts lies on the y-axis. Time and date lie on the x-axis. Units on the y-axis can be changed with this drop-down menu. We can change the time interval to toggle the window of data displayed. Let's have a look at the calibration panel. We can change some of the internal settings on the Ranger with this panel. It is best to leave the calibration settings alone unless you are an experienced technician calibrating the meter. We have calibration date, dead time, sensitivity, and isotope efficiencies. I did change the efficiency on the alpha setting earlier to accommodate our plutonium-239 source. The other settings are safe to change. Alarm settings. We can enable or disable the alarm and change the threshold on the Ranger unit. This is the preset counting time in seconds. Enter the number of seconds to set the time for taking a time count. We had set it to 60 seconds earlier on the Ranger unit. Here are the data logging settings for the Ranger. Use data logging on Ranger, enable or disable. Data logging interval in minutes. That is set to 1 minute. This interval can only be changed on the Ranger through this software. Circular buffer. When this box is checked, the oldest collected data will be overwritten with the most recent data collected. Clear memory. That is self-explanatory. Backlight on time. This sets how many seconds the backlight will be on when pressing the backlight button. It is set to 7 seconds by default. Display mode changes the units on the Ranger. Contrast. This sets the contrast of the LCD display on the unit. Auto-averaging. This enables or disables the auto-averaging feature. When unchecked, the Ranger is in fast response mode. Clicks enabled. This enables or disables the audio clicks. Quiet mode. This disables all sounds except alarm and overrange. We can update or close without saving the changes. From functions, you can synchronize the Ranger to the PC clock to update time and date on the meter. By activating Retrieve Memory, you can download data from the internal memory on the Ranger from previous readings taken in the field. The data will be stored as a text file, which can be imported into Excel. And here you can save the current graph values and the grid values to your PC. That was our demonstration of the Ranger. For more detailed specifications and ordering information, please follow the link to our website.